I was trying to figure out what time it is. Good afternoon, everybody. This is going 0 to 60 with Elastic Beanstalk. We're going to start at a very simple sort of level where, assuming that people in the room don't know much about Elastic Beanstalk, just a quick show of hands, how many people have used Elastic Beanstalk before? Seems like a good chunk of people. So bear with the early portions. It might be a little slow for you guys. I just want to make sure that we cover for beginners and then go into advanced topics. All right. So my name is Abhishek Singh. I'm the Senior Product Manager for Elastic Beanstalk. So let's get started. So what do we as the Elastic Beanstalk team believe in? Why do we do what we do? Our beliefs are that we believe in helping developers deploy and maintain scalable web applications and services in the cloud without really worrying about infrastructure. We're going to start with what does Beanstalk do for you? Elastic Beanstalk allows you to easily deploy, monitor, and scale 3-tier web applications and services. We provision the infrastructure, we manage the infrastructure, but at the same time, we provide you as developers using Elastic Beanstalk complete control to customize that infrastructure or the application stack if you so choose. We provide pre-configured application containers. As you can see on the screen, we support .NET, PHP, Java, Ruby, Docker, Python, and Node.js. And all of these platforms are fairly easily customizable, as we'll see later in the presentation. So let's quickly talk about what we're going to see here today. We're going to start with some of the basic concepts of Elastic Beanstalk. So what's the object model that Elastic Beanstalk uses? Just to give you guys an idea of how applications sort of map to that object model. Then we're going to talk about the developer workflow. We're going to use the command line utility or the command line tool that we have for that. We'll show you examples of some of the other tools that we integrate with. We'll do a demo. For the demo, we'll be using one of our recently released pre-configured Docker containers. So we'll show you how to do dev and test locally using Docker containers and then deploy the same application to Elastic Beanstalk, knowing that Elastic Beanstalk is going to deploy to that same exact container and knowing that you have a very high fidelity deployment. And the last piece on there, we'll cover some advanced topics. Now, these topics may not be really advanced for developers who work with Elastic Beanstalk. It's mainly advanced topics for you to research, go learn about. I'll touch on some of the basics of zero-downtime deployments, how do you do customizations of software on the Elastic Beanstalk platforms or the application containers, and then how do you configure additional resources in terms of AWS resources as part of your application. All right, so let's begin with basic concepts. As I mentioned, we're going to start with the Elastic Beanstalk object model. So in Elastic Beanstalk, you basically have 3 objects. You have applications, and under applications, you have these 3 objects. You have environments, application versions, and saved configurations. So as you can see, environments are basically what consists of your AWS resources. So for example, EC2 instances, your ELB load balancers, your auto-scaling groups. These environments run a single application, version at a time. This is for better scalability. And an application can have as many environments. So for example, you want to do blue-green deployments and you want to have a staging and a production. You can have multiple environments within an application. Then we have application versions. What this is really application code. It's stored in S3, so it's highly available. And an application, again, can have many application versions. Specifically, we use these to allow you to do easy rollbacks. If you've deployed a version that's bad, you don't ever have to go figure out what was the previous version that was deployed. We show it very easily to you on our dashboard, and you can roll back. And the third piece is saved configurations. Now, these are configurations that define how an environment resources behave. So for example, you've set up an environment and you've customized some load balancer behavior. Next time you go to create an environment, you don't want to redo that from scratch. So what you can do is you can save a configuration, which basically creates a snapshot of your current environment, and then allows you to recreate it. And you can have as many of these as you'd like. So let's look at Elastic Beanstalk environments. We have two types, a single instance and a load-balanced auto-scaling environment. The reason we have two types is because as developers, you want to ensure that you're working on a single instance environment. You don't have any runaway costs. You're always guaranteed that it's only going to be one instance. If somebody figures out your URL and hits you with a lot of traffic, you don't want the environment scaling and increasing your costs. The other benefit of using single instance environments is you can actually test your applications to make sure that they degrade gracefully under load. I tend to stress this point because it's really important. What I've seen a lot of developers do is they'll throw auto-scaling at the issue. So they have an application. They'll be like, hey, I want to do 10,000 requests in an hour. Let's just set up auto-scaling to give me 100 instances and then run a load test. And all of a sudden, you'll get 100,000 requests or 10,000 requests per hour. But what you've got an issue with is as soon as your instances are overloaded, each one of them will go down because the application's not architected correctly. So I always recommend developers test their applications under load on a single instance environment to make sure that the parameters are set up appropriately so that that single instance degrades gracefully if it's overloaded. The second environment type that we talked about is load-balanced auto-scaling. This is what we pre-set up for production environments. It has an auto-scaling group, and it has a load balancer in front of it. So these environments will automatically scale given the load that you're putting on the environment. So it's basically pre-set up for you. You don't have to worry about what should I do for scaling. Is my instance going to be able to handle all the load? As long as your application's architected correctly, Beanstalk's basically going to do the rest for you. And as I said, Beanstalk provisions the necessary infrastructure resources. We configure Amazon Route 53 and give you a unique domain name. So if you don't want to pay for a domain name, you're just testing an app, we give you a free CNAME that you can use to ping your app. This is one of the pieces a lot of people don't get about Elastic Beanstalk is a lot of developers make mistakes here because they try to recreate what they are used to with Amazon EC2 or on their developer workstations. They try to set up the exact application stack, and they're like, hey, I need to install Python, I need to do this, I need to do that. You don't actually need to do any of that with Elastic Beanstalk, because we pre-configure your EC2 instances to have the application container that you've selected already pre-installed on there. All you really need to worry about is manage your application and any dependencies that your application has. So in this case, the graphic really shows the HTTP server, the application server, the interpreter for the language, the operating system, and even provisioning of the EC2 hosts is done by Elastic Beanstalk. So a little graphic to show the correlation of environments with application versions. So basically, what you've got in blue is an application in our object model. In there, you have two environments. You have a test and a production environment. And then you've got a whole host of application versions that you can have there. And the green one is sort of the actively running application version, which will be tagged as such. So let's quickly look at developer workflow, because this is the crux of Beanstalk, is to make it easier for developers to get their apps up and running on the cloud. So we've got a whole host of deployment options. We've got the AWS Management Console. We've got, you can use Git with our CLI. We have toolkits for Eclipse and Visual Studio. And we have a whole host of partners that have CI integrations that work on Elastic Beanstalk. So what do you need to deploy your application to Elastic Beanstalk? So as you can see, the first thing you need is your code. You need to know the region you want to deploy your code to. We're in 9 public regions out of the 11 AWS public regions, I believe. And we'll be in the other ones fairly shortly. You need to know your stack or container type. So are you running a PHP application? Are you running a Node application? Or do you want to deploy a Docker container? That's the other piece of information that we need. And then we have single instance or load balanced environment. So which type of environment do you want? Do you want something that you're using for testing, or do you want something that you want to run a production load on? And optionally, we can provision an RDS database for you if that's what you choose. Our recommended way is if you provision, so one thing to note is in Elastic Beanstalk today, the lifecycle of the RDS database is tied to the lifecycle of your environment. So our recommendation is to use the database provisioned by Elastic Beanstalk for dev and test only. And if you want to do production, generally you want the data to stay longer than the application or the environment stays. So it's recommended to do that separately. And I would mention CloudFormation is the best way to do that because you can template your infrastructure. So I would highly recommend looking into that. All right, so we're going to look at our example workflow of using the CLI. So what do you need to use our CLI? You obviously need your AWS account credentials. You can install it on Windows, Mac, Linux systems. The prerequisite is Python 2.7 or Python 3. On Windows, PowerShell. And then you need Git or later, Git 1.66 or later if you're going to use Git to do deployments. So let's quickly look at our example workflow. So as a developer, when you start deploying apps, you've got source control. So you go in and you initialize your repository in your folder. So you do a git init. And then we use the EB utility. So we'll do a EB init. What EB init does is it initializes your folder with some configuration files so that the EB utility knows what environment that folder is tied to or that application is tied to. Anytime you do git init or set up a directory for the first time, we recommend running EB init. EB init also lets you, for example, you've got multiple developers and you want them to work on the same environment at the same time. With our newly released version 3 of the CLI, we've actually moved all the configuration options into the cloud, so you can actually have teams deploying to the same environments without actually worrying about data being stored on the instances or, hey, is my sensitive data going to get code committed? Because we've taken care of all of that because there's nothing on your instance or on your desktop. EB init is interactive if you don't specify any options. There's a whole host of command line options that you can specify. If they're not specified, it's interactive. So it will have a bunch of prompts. You go in, you fill those out. You obviously write your code. You make sure to run git add so that all that code is in the repository. And then you do a git commit. One of the questions that was raised earlier is, do you need to do git push? You don't actually need to do git push here because EB deploy builds a local archive and then uploads it. So you don't actually need to have the changes pushed into your repository. However, that is a good idea if you are using GitHub, for example. And then that's basically the first step of how do I get my app onto Elastic Beanstalk. Now, as developers, we're continually developing code. We're continually changing code. So what's the workflow to update your application? You basically update your code. You do a git add if you've added new files. You do a git commit. And then you do an EB deploy. And what EB deploy does is basically creates a source archive from your Git repo and then pushes it up to the Beanstalk service and then deploys it onto your instances. And then you can monitor the deployment progress using EB status. All right, so let's look at how do you deploy Docker containers to Elastic Beanstalk. We've got 3 ways to do this today. You can use a Docker file. If you use a Docker file, the images are built on the instance. Elastic Beanstalk supports both the public Docker Hub repository and private repositories. So if you wanted to set up a private repository, you could. The second way to do it, if you already have an image in a private repository or on Docker Hub, you can specify a docker run.aws.json. This is a manifest file that's specific to Elastic Beanstalk. What this file basically specifies is the name of the image that you want to run on the Elastic Beanstalk container, and then any port mappings or file mappings that you need. So as you can see, there's an example on the right side there of two little snippets, one from a Docker file that basically gets Nginx up and running, and then another one which is a Docker run file that uses the WordPress example on Docker Hub. What are some of the benefits of using Docker? One of the things that we've seen, that we've heard from our developers is a lot of times you're developing on your desktop, and this goes back to managing configurations. You've got this snowflake on your developer machine where the developer has installed all these things, and then their app is working on the dev desktop, but when they deploy it to the cloud or to Elastic Beanstalk, it doesn't work because they're missing a dependency or something is missing. Docker basically allows you to make that consistent, really provide a high fidelity between your local machine and the cloud, or the Elastic Beanstalk environment in this case. The other big benefit, which a lot of people don't realize, is with Docker, you own the runtime. So if you want to build an application that uses Go, you can go ahead and write a Docker file and do that, even though Elastic Beanstalk doesn't officially support Go, or we don't have a container that supports Go. If you want to do Scala, Clojure, the Play framework, you can do all of that using Docker on Elastic Beanstalk, and really simplifies, or expands the possibilities, I should say, that we provide to our developers. So we're pretty stoked about that. And again, this looks like very similar to the previous slide that we had, but how do you deploy a Docker container to Elastic Beanstalk? Simple. Do a git init on your repository so that you have it under source control. Do a eb init. Follow the prompts, copy your Docker file into the folder, git add the Docker file, git commit, and do eb create. Eb create automatically deploys what's in the folder. So there you go. Basically, it's that simple to deploy a Docker file to Elastic Beanstalk and have it up and running. All right. So now let's get to the fun part. Let me log in here, and we will move over. Perfect. All right. So let's begin. Got this little Vagrant box running over here. It's running Docker. As those who've used Docker, you need a virtual machine to run it on Windows. What we're going to deploy is this application we've got. Again, it's on GitHub. So if you go to github.com/AWS Labs, we've got a bunch of samples with the EB prefix. So we've got this Flask sign-up application for startups. So you're a startup. You've got this new product coming. You want to collect people's emails. We've got this nice little app written in Flask that you can get started with. So we're going to use the master branch. This does have multiple branches. So we do have a Dockerized version of this that runs on our Docker container. We're going to use the master branch because I'm going to show you guys our new Docker pre-configured containers, specifically our Python 3 container that we recently launched. So let's go ahead in here. I'm going to pull this up, just quickly see where I am at. OK, so I'm in the pre-launch folder. Actually, let's go ahead and do the whole thing. So I'm going to git clone. And OK, there we go. All right. And then let's check out my Python 3 branch. So I've got that there. And now let's quickly do a ls on here. So as you guys can see, I've got this dockerrun.aws.json file. And the reason I have it here is because I'm mapping some folders. So I'm going to pull this up here so it's easier to see. So all this file is doing is basically saying, hey, we're using version 1 of the dockerrun.aws.json file. And I want to map etc config on the host to etc config on the container. And the reason we do this is because this app has a dependency, which is this config, that goes in /etc config, which I can show you guys here very quickly. One of the other things we'll touch upon in the advanced topics is these EB extensions. But I quickly want to show you guys, just walk you guys through some of the things that happen in here. So in here, we're basically saying resources. We're setting up a DynamoDB table. That's where we're going to store our emails. We're setting up a new queue, because we're going to drop the emails in a queue and not process them synchronously with our front end. That's just a bad thing to do. And then we're setting up an SNS topic. This is what actually sends the email to the customers. And then we've got these properties, subscriptions, endpoints, and we've got this option setting, which is new sign-up email with default at nobody@amazon.com. Now, one caveat for the demo I want to mention is this email hasn't been vetted by our email service, so the email actually won't go out. I don't want to type in my email address because I don't want spammers to use that. Not that anybody here will spam. And then what we're also setting up is some policies, or IAM policies, around making sure that my environment has the appropriate permissions to send a message, create the queues. And specifically, we're referencing the ARNs, or the resource identifiers, for the queues that I'm setting up for this environment. So this ensures that no other environment, or this environment can't access any of your other queues or resources, making this a very secure architecture. And then as I mentioned down below, we have on etc config this app.config file, which actually makes some of these things configurable. So you can actually have an environment variable with AWS region, and then that will automatically get put in, and when you do a deploy, we'd be in that region. So that's just a quick view. Let's get to the crux of it here. So I've got this. With our recently released Docker containers, we require a Docker file if you want to test this locally. So what I'm going to do is quickly add a file here. And I'm going to copy it from the demo that I already have. So we're going to go there. So this is our image for the Python 3.4 container that's on Docker Hub today. So we're basically going to say put that in because we want to test the application locally just like it would run on Elastic Beanstalk. So I'm going to go ahead and save this. It's just that one line. That's all you need. And I'm going to call it Docker file, because that's what Docker expects when you build an image. I'm going to go in here and make sure it's here so I see my Docker file. So I'm going to run a Docker build. My Flask image. Oops. Always forget that. So there we go. I already have the images cached in the interest of time. So basically what I just did was tell Docker, go ahead and build my Docker container with my application in it. So as you can see, it's using var app. It's going and doing a bunch of builds. It's going to pip install a bunch of dependencies, in this case, Flask, Bodo, and as you can see in the last line. So basically, just building up my Docker container here. And then I am going to run this. I want to copy a file because I have this saved in the interest of time. Flask. OK. And let's make sure I have permissions on that. OK. All right, so I'm going to quickly show you guys the run file so that you know what I'm running. Basically, it's just a simple bash script. It calls docker run, uses IT to run this in interactive mode so that your command line actually waits. It uses --rm, so there's an automatic cleanup once the process is exited. We set up 3 environment variables that are necessary. We say map port 8080 on the container to 8080 on the host. Beanstalk images use 8080 by default, so that is a requirement. And then it says use pre-launch app image. So I'm actually going to modify that because that's not what I called mine. So let's go look at what did I call mine. It said my Flask image. So I'm going to go in here and go my Flask image. All right. So now I have that. What I'm going to do is run it. So basically, Docker is running my container now. So let's go ahead and hit it. And boom. You've got this application running locally in a Docker container. It's a Docker image that we've provided. In Beanstalk, I quickly want to show you guys how that would look. So I have this pre-baked environment. So basically, that's the app on Elastic Beanstalk, and that's the app running locally on Docker. As you can see, we have some additional information that we put out here just to make sure you know where you're running. But it's basically the exact same thing running in two different places. Wanted to quickly show you guys through creating an environment. So when you select web, what we've added is these new Docker pre-configured containers. And we've made these images available. So the from line in my Docker file that I added was basically the image for that Python container. And this, excuse me. And this pre-baked environment that I have is basically, as you can see, it's running Debian Jessie on the Docker container. And it says it's a pre-configured Docker container with Python 3.4. So quickly go in here. So next big thing is coming. OK. So now just want to show you guys that it all got cleaned up. So there's no processes running. That's why I used -it and --rm. Let's quickly go make a change. And with my luck with demos, I don't know if this is going to work today or not, but hopefully it will. And index. Why am I not seeing this file today? Sorry about that. New startup, sign up today. Oops. So I want to change the next big thing is coming to the next big thing, or well, I shouldn't say the next big thing is reinvent, because that would be inappropriate. Let's just change that to the next big thing is here. And I did that in the right file. So what I'm going to do is I'm going to go ahead and build my Docker container again. Just to make sure I'm testing it locally, making sure that I'm running this locally. I have this developer cycle. I don't want to upload constantly. I want to get my app running exactly as I wanted. So we're going through and building effectively version 2 of our app. Perfect. And I'm going to run my run script again. Boom. All right. Let's go check this puppy out. So there we go. So I just made a change, built the Docker container again. My change is here. Now let's do the fun stuff of actually getting this change up to Elastic Beanstalk. All right, so I don't need my Docker file because Elastic Beanstalk already has that set up. So I'm going to change that to dockerfile.local. And then I'm going to do ev init. I'm going to use Oregon there. Yeah, that is definitely interesting. So that file is there. Interesting challenge. Well, here's how I go around it. Not do the deploy on, as I said, my luck with demos today is not working out. Hold on one second. I'm just going to use the pre-baked environment here. Pre-launch. See if that works. Oh, okay. Let's go quickly here. Okay. All right, we can fix this. I'm going to take this off quickly so I can actually enter that information. That's okay with you guys? Perfect. Oops. See. Okay, let's go. Docker. Wow. All right. Having some issues there. I will use my backup method of deploying. Okay. All right. We'll just deploy using the console or the management console. So what I'm going to do is quickly go in here. That's my folder. That's what I want to use. Don't want to upload that. I'm actually going to kill that. I don't want to upload that, so I'm going to kill that. Don't need that guy. I'm just going to zip this up. Perfect. All right, and then we're going to go into our management console and do an upload and deploy. I'm going to change this. Actually, I only have one instance running, so rolling application deployments is not really going to matter. But I'm going to go in here, and I'm going to pick that file. All right. So instead of using EB deploy, we're going to use the console, the web console, to do this. And basically, what we've done is just deployed the update. So we want to see the next big thing is here on that same space there. So we'll wait. In this case, the same process that happened on my desktop is actually happening on the Elastic Beanstalk environment. So each instance is pulling down the image. In this case, hopefully it's already cached because it's been built before. And it's building your application into the Docker container. So that's why this does take a little longer than doing a deployment of just a source to Elastic Beanstalk. So we're waiting. While we're waiting for this, oops, didn't want to do that. I'll just go rotate the keys. That's the that's the good thing about being able to rotate keys and all of that being transient. All right, so now my container is deployed. Hey, the next big thing is here. So eventually that works. So basically what we just did, as you guys saw, was deploy a Docker container locally, test it, or should I say it right there? Test it, do my iteration on my developer desktop, and then actually push that to Elastic Beanstalk, and works exactly the same way. So that's the quick demo. We've got about 9 minutes, or my clock says 12 minutes over there. OK. So let's quickly talk about some of the advanced topics. As I mentioned, this is going to be some advanced topics around how do you customize your application containers, how do you customize or add resources that your application requires to your Elastic Beanstalk environments. So we're quickly going to look at an EB extension or a config file that installs the New Relic agent. So say you want to send metrics to New Relic. You write a little simple EB extension, and you can have that running. Say you want to use Splunk, do the same exact thing. So these containers are infinitely customizable. We don't lock it down. We understand that as developers, you want control. And when you do want that control, we let you have that control. You can iterate on your application's architecture. So in this case, we have an example of adding an Elasticache node and then saying that we'll use memcached as the engine. But you can use a similar snippet to do DynamoDB tables, as I showed you guys earlier. You can use a similar snippet to do SNS topics, pretty much any resource that CloudFormation supports, because at some level, these are just CloudFormation snippets that you're using. Let's talk about zero-downtime deployments. This is very important to developers as you're iterating in today's world. You want to do this very quickly. You want to develop very quickly. And you don't want to have your deployments take down your traffic. You want to continuously serve your customers' traffic. Beanstalk realizes that people have two ways they go about it. There's the immutable architecture track, which basically says, hey, I want to always deploy to a new set of instances, a new environment. I never want to do in-place deployments. So for that, we support something called swap URLs. The way this works in Elastic Beanstalk is that you would create a new environment for your new application version, and then you'd deploy your updated code to it, and then you'd perform a swap URL. And what that basically does is it swaps the DNS entries at the top so that your old environment or old DNS entry is now pointing to your new application code. This has some downsides, specifically if you have devices that cache DNS addresses that don't respect the TTLs. Your customers can continue to get the old version of the application for a little while. So for that, what we've done recently, we launched 2 weeks ago, rolling application deployments. What that allows you to do is roll your deployments across your entire fleet of instances in your environment. So you can say, hey, I want to deploy a new application version, but I don't want to deploy it to 100% of my environments. I want to deploy it only to 30% of my environment. And then I want to roll it 30% at a time. So Elastic Beanstalk now has that capability too. And that allows you to do in-place, effectively in-place zero-downtime deployments. So let's quickly recap what are the benefits of Elastic Beanstalk. Beanstalk basically lets you, or at least we hope that Beanstalk lets you focus on your application. It focuses on what makes your business unique. It allows you to focus on innovation, not doing the undifferentiated heavy lifting of setting up your environments, configuring your application stack, how do you deploy your applications. We want to do all of that for you so that you're really focusing on your core business and what differentiates you. It allows you to spend developer time in the right places so that developers are not worrying about writing scripts to manage infrastructure or manage configuration on the instances. And it allows you to automate as much as you can. I can't stress that point enough. Everything you do, you should automate. It allows you to be more agile. It allows you to do things much faster. So if there's one thing that you take away from this talk is automate as much as you can, because that will really save your bacon when it comes down to SWOT type situations. And then the kicker, obviously we don't have any additional charge for Elastic Beanstalk. It's a free service. You only pay for the underlying resources that you use. So you only pay for the instance hours on EC2, requests and traffic on ELB, and S3 storage if you have any. Plus, if you use any additional resources, you would just pay for those resources. We don't charge anything over that for Elastic Beanstalk. Some links to make note of if you guys are interested in learning more. I highly recommend downloading that Kindle ebook. It's a blog post that we had. It's a 5-part series we did on developing, deploying, and managing for scale using Elastic Beanstalk and CloudFormation. It is by far the best, I would say, 2 hours you will spend in learning about CloudFormation and Elastic Beanstalk. We have a blog, which we update fairly regularly, application management blog, so I would highly recommend you guys follow that for updates as we make updates to our service and new features and use cases. We're also on Twitter, so follow us at AWS EB. And thank you, everyone, for coming. Hopefully, this was useful. We're not going to take any questions in the room. I'm going to be waiting outside to take questions, so anybody who has questions, feel free to grab me. Hopefully, this was helpful. Would love you guys to provide us with some feedback on the link, bit.ly link there. Helps me improve when I come back to get you guys up and going next year. So thank you very much.